Okay, we're live. So we have taught what we have done so far. Let's just think about where we have come and what we've been doing over the last week, right? We've been talking about systems of equations. Systems means how many equations?
More than one.
More than one, right? And when you're looking to solve the systems of equations, what are you looking for?
Equation?
You have two equations, two lines. What are you looking for?
The answer set.
Which is what? How do you know it's the answer?
Where both lines cross.
Both lines are crossing, right? That point where they both cross, that's all you're looking for when you're doing all the systems of equations. Even if I gave you three sentences, three equations, right? You'd have to have three that cross exactly at the same point, right? That's a little less likely to happen, right? Because they're likely to cross at different places. But if you have two and they don't have the same slope, they are going to cross. You guys agree with me?
Yes.
They're going to cross somewhere. It may be out in outer space, but they're going to cross, right? That's almost parallel, but that's really not totally parallel. Somewhere those are going to cross. You know what I'm saying? When you go far enough, right? So that's all you're looking for, where they cross. And so what we have done is we've done three different methods. We have learned how to solve systems by, what's the first method? Graphing, right. So that was the first method we learned. And then we said, but graphing doesn't always work very easily. Because it doesn't always neatly come right smack on the grid corners, right? Sometimes it's in the middle and that's messy. We don't know what it's going to be, so we have to know how to do it algebraically. So what was the second method we used?
Interception.
Substitution. Right? Interception is the idea, but substitution is substituting it in, right?
Yeah.
Figuring out, okay, we find an x equals or a y equals, and we circle that. Remember that?
Oh.
This was a while ago because we took a little brief advertisement out of our normal thing to work on computer science and actually coding, because this is the National Computer Science Education Week. So we decided to devote 2 days to coding. So they're a little rusty on the substitution because that was last week. But they're getting it. They know how to do it. If I put it up there, they'd know how to do it. I know that. But then we decided, let's look at that last method, which is elimination. We eliminate that guy, right? We eliminate either the x's or the y's. So now we're going to look at that a little bit further. We're going to go deeper. You've seen it one way where you just added the two equations together, right? And the coefficient, for example, if we had, this was the first one we did. We did like 2x plus 3y equals 10, and we had minus 2x plus 6y equals 12. And we just added them together, right? We just added those two equations together. And what happened? We eliminated our x's, right?
Yeah.
Okay, that was the first time we tried these, right? And then we did this. We had something like this. 3x plus 2y equals 10, and 3x minus 7y equals 12, right? And we notice we're looking at the coefficients, the numbers in front of the x's, right? Or the numbers in front of the y's. I've got a 2 and a negative 7. Ooh. Those aren't going to eliminate easily, are they? But those, right now, the way they are not going to eliminate. If I added these together, I'd have 6x. But what would I have to do to make these eliminate?
Subtract.
Multiply one of them by negative 1. I don't know, it doesn't matter which one. So that means I have negative 3x plus 2y equals 10. And I'll just rewrite this one here. 3x minus 7y equals 12. And then I add them now, and look, I eliminate my x's, and I can easily solve for my y by just adding those. Question? No.
Wait, whenever you times one side of the equation, when you do negative 1 times 3x,
thank you.
You have to do it to the other side.
Oops.
And
Oops.
the 2y.
Yes.
And the 2y.
Good job. Good
And
job.
2y.
Did I do that? Jeepers, creepers, bubble leapers. Okay. That is, I'm glad you guys caught that. That was totally, I did that on purpose to see how well you guys knew.
Oh,
Right? Math teachers love that one. Okay, that's awesome. So now we are going to look at one step deeper. Okay? We're going to take what you know, and we're going to still use elimination, but I'm going to give you a problem that doesn't work quite as easily as either of these do that I've shown you. Okay, so let me write up the new equation, new sets of equations. So we have 4x, let me think about it. I gotta rewrite this. 4x plus 5y. 4x plus 5y equals 35. 4x, okay. 4x plus 5y, I forgot what it was, equals 35. So write this down in your notes.
Gary, can I get another pencil?
And then we have, yes, you may.
Thanks.
And then we have negative, oh wait, hang on a sec, what happened? Oh, sorry, I'm gonna, sorry. Now that you've written that, erase that. Sorry, I thought I had these figured out, but I didn't. So,
Gary.
all right, here we'll do this one. 6x minus 2y equals 1. 6x minus 2y equals 1. And then where's the next one? Negative 2x plus 3y equals negative 5. Negative 2x plus 3y equals negative 5.
I feel like we're going to do diagonal.
You feel like what?
No, we're just going to do diagonal.
Did I write that one down? Right. Negative 2x plus 3y equals negative 5. Yes, okay. All right, so you look. Yes, just 1 second, Graham. I'll ask you to tell me what to do in just a second. But I'm going to tell you what the first thing is you look for. You look at the coefficients of the x's, and you look at the coefficients of the y's. I have a negative 2 and I have a 6. I have a 3 and I have a negative 2. If I added these right now, I would not eliminate anything, right? You agree with me? Because in order to eliminate, one of them's got, the coefficients have to be the same number except one's positive, one's negative, right? So what would you do, Graham?
The bottom one you can multiply by 3, and the top one you can multiply by 1.5.
By what?
And then
By what?
1.5, because then negative 2y would be 3y. I mean negative 3y, and then those would cross out as.
And why? What? The bottom one you multiply times what again?
3.
Why?
Because negative 2x times 3 would be negative 6x, and then
Okay.
those would cross out.
All right. So you went a little too far.
Okay.
All you needed to do was one of those.
Oh yeah.
Right?
I'm
Because
saying
you're
you don't
only
want
wanting
this.
to eliminate one of them. You don't
Yeah,
want
I'm saying
it.
you
He
don't
was
want
trying to
this.
suddenly eliminate both of them.
Oh no, I was just.
But that
telling you
wouldn't
two
have.
ways that
Oh, I see.
you
You said
can
two
have
ways.
it.
I get it. I see. Yeah. So there are always different ways you can do it, right? So he said, "Oh, well, can I multiply negative 2 by something to get 6?" And you always look at the smaller coefficient, right? The smaller coefficient is negative 2. Can I do something to that? Multiplies that by something to get positive 6. Actually, negative 6 in this case, right? I want to keep it negative, right? I want it to be the opposite of this sign. So he said multiply times 3. Or here, could I turn the 2 into a 3? I guess I could multiply it by 1.5, right? And then I'd get a 3 there, a negative 3 there.
Wait,
Right.
how does multiplying something by 1.5 make it?
Well, my recommendation is don't do the ones that are decimals, right?
Yeah.
Choose the easier one, right? And the easier one is going to be this. If I multiply this times 3, you see how that's going to be positive 6x and that's going to be negative 6x?
Yeah, I
That's
get
what I
that.
want.
It's just I don't understand how multiplying a whole number by a half of a number makes it a whole number.
Because 2
Because
is
2 times
Oh,
5 is
okay, I
10,
get it.
right? So
Yeah.
then it's 3. It's 3. See what I mean? It works. It doesn't always work. But that's a good question because it doesn't always work. But when it's 1.5, when it's 0.5 something, then it will. It will. Yes, you may. Thorne, question.
Wait, couldn't you just switch the 6x with the negative 2x, so it'd be negative 2x minus 2y?
No, because then it's x can't minus a y. X can't be
Right, because you
subtracted.
got to have like terms, right?
Yeah, no, but if you did that, then no, it's wait no.
X
Do that.
minus y.
So then it'd be y minus y, and then x minus
x plus x.
So wait, say what you're saying. Say it one more time. What would I do?
Okay, so you would make it so that both lines have the same variable, so it'd be 2x plus negative 6x. So
Wait,
then
2x.
4x
But see, I
is-
can't do that. I can't. That's a great question. At least as far as I know, I can't do that. I'd have to play with that. It's an interesting thought because I haven't ever thought to try that. And that's how mathematicians learn new things, is they get these wild and wacky ideas, right?
Yeah, there's no reason why you can't just divide that first line by 2.
But to my knowledge, you can't do that, right? At this point in time, you can't move them into other equate. You can't take this 6x and move it over here, and take this 3y and move it up here. You can't do that because this is an equation. This is an actual line, right? It's a straight line. As soon as you do that, you've changed the line. You see what I'm saying? So now you've got a different point where they're intercepting by just changing the lines, right? So the whole idea is, if we multiply both sides by the same number, then we haven't changed the equality of this side and this side. We've changed the equation a little bit, but actually, ironically, if you graphed it, it would be the same equation. It's kind of weird, and I'll show that to you sometime. But right now, let's just try this. If I multiply this out, I've got negative 6x plus 9y equals negative 15, right? And then I'm going to do 6x minus 2y equals 1. And then I go like this, and I add my two equations together, and look, I eliminate my x's completely,
I don't know.
right? And so now I have 7y is equal to negative 14.
What'd you do?
Divide by 7, y is equal to negative 2.
Yes.
All right?
Okay.
And then what do I do?
Then
Oh, yeah, no.
you plug the y part into the top problem, I guess.
Either
It's not-
one, but I'm going to use the top one. It's so easy. So 6x is minus 2 times negative 2 equals 1. It's much safer when there's negative signs to write it first, because then you can really see that's going to be a positive 4, right? Whereas it's so easy, if you do this in your head, you're going to, so easy to just say 6x minus 4 equals 1. And you get it wrong. So 6x plus 4 equals 1, so I'm going to subtract 4. Subtract 4. I have 6x is equal to negative 3, right? Divide by 6, divide by 6. X is equal to negative 3/6, which is equal to negative 1/2, right? Right? Is that what you guys got?
Yeah.
Awesome.
I just put negative 0.5, but.
Yeah, negative 0.5 is the same thing. That's fine. Right? So make sure you've written that down. Have you written that all down?
Yeah.
Henry? So that's the process. Fist to 5. Do you get the process? Does it make sense to you? So I'm going to just put a couple up, and we're not going to finish them. I'm just going to have you, because they're not necessarily ones that are going to work out easily, right? I just want you to tell me what you do, okay? So is that fair? Let's just try, just to practice. Don't erase.
Yeah, don't
erase.
unrace it.
Should we write
Okay,
them
I'm
down?
going to use different colors.
Should we write them down or not?
Hopefully.
Should we write them down again?
What?
Should we write them down?
You don't have to. All you have to do is listen. Just trying to find a
Can we put our,
marker I like.
elsewhere?
Okay, I'll use a black one. Oh my gosh.
Use that bright red one that you found.
How come all our markers have disappeared? Okay, that's pretty good. All right, here we go. Here we go. You must be seeing. Okay, so 3x plus 4y equals 10, and 2x plus
Yes.
y equals negative 2. Tell me what you would do.
Okay, should we write that down?
You don't have to write it down. Just just watch me. So I noticed my smaller x's is 2, my larger one is 3, my smaller y is 1, hidden 1, and my larger y is 4. What would you do, Thorn?
Plus 3x by 2x, so 5x plus 5y.
Right, but the whole idea is that you're trying to figure out a way to turn the coefficients of either the x's or the y's into the same number, only one's positive, one's negative. Then when you add them, you will eliminate one of them, right? Okay, Lucinda.
I multiply it by -4.
What were you going to say, Aiden?
I'm gonna say multiply by.
Yeah.
Which one? The bottom one?
Yeah.
By -4, I agree. That's what I would do. And then that would be -4y. When I add them together, the y's cross out. Does that make sense?
Oh, yeah.
Get that? Okay. So here we go. Let's try another one. 5x minus 7y is equal to 12 and let's see here. What's it going to do for that? Good, Gary. Okay. So okay, 10x plus 2y equals 10. What would you do? Somebody else. Somebody else that's brave. I want somebody that hasn't. Okay, Gabe.
Multiply 10 by 2. Or multiply the bottom by -2.
Multiply the
No,
top by
you
negative.
multiply
I would multiply
wait.
the top by negative.
Yeah.
The top by -2. Exactly. That's what I do. I multiply that one by -2. Everything in it, right, gets multiplied by -2. That would be -10x and positive 10x. When I add them together, they eliminate,
Actually, no,
right?
divide the bottom by 2 or 2.
Yeah, you can do that.
You could actually, in this case, you could divide the bottom one by 2 because they're all divisible by 2. That's another option. Totally another option. Okay, how about one more? What time is it? Okay,
10:02.
maybe. Do we want one more?
Yeah.
Okay, so 8x minus 2y equals 0 and 2x minus 12y equals 4.
Times
Multiply the
-2
bottom by
multiplied.
-4.
Say what?
Multiply the top by negative. No, by
The bottom by -4.
Okay, so there's two possibilities here, right? Are you noticing?
The bottom by
The
You can multiply the top by
By-
6, because
You
then
could multiply the top
by 2.
you could multiply the top by -6, right? And then that would become positive 12y and negative 12y. Or you can multiply the bottom by -4.
Why negative?
That would be 8x and -8x, right? Right? So you see, you have two options in this one, right? And you just choose whichever one you want to do. If you don't know what, if you know your 4 is better than your 6 timetables, use the 4.
Well, I think it would be easier to like multiply the top or by the top one, or multiply the top one because like then you don't have to
No,
multiply
you
12 by
divide 12 by negative
12 by
Oh, 12 by 4, right?
Yeah.
By
Oh,
-4,
that's
yeah.
yeah, but
Yeah.
it's like
All right, so that's good. So that's it. I'm going to turn this off.